So today we're doing more of trigonometry, but we are going to focus on tangent. So tangent is a lot different. Before we hit on tangent a little bit, let's just kind of recall a bunch of stuff that we have learned about sine and cosine. So cosine of our angle, we have a wavelength of 360 degrees if we're in degree mode, or if we are in radian mode, we are in 2 pi. And for all of these, actually, we do have a wavelength formula. Either 360 over b, or if we're in radian mode, 2 pi over b. Okay? So this works for sine and cosine because they are both identical as far as wavelength, and this formula works for them. So as an example, just to kind of rehash, and we'll do this in degree mode, if I had the equation y equals 2 sine of 4x plus 15 degrees minus 3. This is my amplitude. So my amplitude is 2. That's how high it is, how tall it is from our midline. This is our b right here. And this tells us that we complete 4 waves as we go from 0 to 360. So there will be 4 complete ones. Okay? This is our phase shift, these two numbers. Actually, mostly this first number. This one just moves the midline up and down, but I like grouping them together as the phase shift question. So in this case, I had a plus 15, so we phase shifted left. Good. Left 15 degrees, and then down 3. So if you can answer these questions, those are pretty easy. That's just picking that apart. And then we could ask the wavelength question, or the period. Your book calls it the period. That's fine. The period is going to be our 360 divided by 4, so 90. So every 90 degrees, our sine function completes its wave. So that would happen 4 times. Okay? It'd be very scrunched, and this would be 360 right here. And, well, I put that in the wrong spot. That should be 0. Okay? So, but we did move it left 15 degrees, so this whole thing would shift to the left 15 degrees. All right. Tangent. So I'm going to erase all this because we already know all that. Tangent is going to be like the weird one. Tangent, and we had said that cosine is related to x values on our unit circle. Sine is related to y values. And tangent is the ratio of sine over cosine. So it's that, which is why it's kind of weird. Part of why it's weird, its wavelength is not 360. And we can use our calculators to verify that in a moment, but its wavelength is 180 degrees. Or, in radian mode, pi. Which does change how we're going to solve the trig equation slightly. Because we have, by default, 0 to 360, we actually complete 2 waves. Because tangent only takes 180 degrees. So our wavelength formula for tangent is going to become 180 divided by b. Or wavelength is 2, or simply pi over b. There's another thing about tangent that's different than sine and cosine. When we talked about sine and cosine, remember we said that their values vary from -1 to 1. But tangent varies from -infinity to infinity. So talking about amplitude for tangent really doesn't make any sense because your amplitude is always going to be infinity. It does. Now we do have an influence when we write our formula. So here's our formula. Y equals A tangent B theta minus our phase shift H plus K. This A still influenced this. This does make it more or less steep. It's a steepness. Like when we did graphing with parabolas and things like that, where we had a stretch factor. A is a stretch factor. Actually, A is a stretch factor also for cosine and sine, but we can use it to find the amplitude. And B is still telling us. Now this doesn't tell us the number of waves, the number of complete waves.
This is steepness, right?
Yep. B is the number of complete waves times 2. Okay? Gives us we have to double it, because if we're going from 0 to 360, remember that we are going to get let's actually do a sketch right here. So here's 180 and here's 360. This will be our rough sketch. On your calculator, what is the tangent of 0?
0.
Yep, 0. And what is the tangent of 90? Error. It means undefined. So what we have happening is that we have an asymptote here that's vertical, and it goes up like this. And let's just say, what's the tangent of 91? Let's get past that 90.
-57.0.
So it gets really small. And what's the tangent of 180?
0.
So this would be one wave. Do you see how weird it looks? It's like goes up, asymptote, down, and then ends here. And then we'll have another asymptote at 270. So it goes like this.
So you put the
Okay, so this would be 0 to 360. I do have asymptotes at 90 and 270. And it goes close, jumps down. That's what it looks like. And we'll practice graphing that a little bit later.
You put the asymptotes where it said error at?
Yes. Error means undefined, or the calculator can't calculate that. Today, rather than focus on graphing, I want to focus on solving. Because we've been talking about solving trigonometric equations, so we'll practice that. Let's say I wanted to solve tan of x, let's put a 5 in front here, plus 3 equals 9. Yep, we are going to have to subtract 3. So I need to get that alone, that piece. And we need to remember this x and this tangent, they're like one thing. This is like, you could actually treat it like this. Solve for a. Okay, so we subtract 3. And we will divide by 5. Good job. So we'll get 6/5. Now, if this were sine or cosine, that's not going to work. So let me write it over here, because we're actually over here. Build your wall if you need to. So 6. So we have 5 tan x. See, this is all one thing. So we divide by 5. 6/5. And now we will do the inverse tangent. So x equals inverse tangent of 6/5.
That's 50.2.
50.2 degrees. Okay? So, now tangent is also positive in quadrant number 3. So I'm going to take my 50.2 and I am going to subtract or add that to 180, and that'll give me another answer.
230.2.
Because quadrant 3. Now, how do I know that it's positive in quadrant 3? Remember this thing. Cosine's positive, sine's positive, tangent's positive. Cosine's negative, sine's positive. These are opposite, so tangent's negative. Cosine's negative, sine's negative, tangent's positive. And finally, cosine positive, sine negative, tangent negative. So we want to know that. That will make a good quiz question, because I know that we're going to our calculator to get these extra answers often. So let's go ahead and use our calculator. We can, of course, put this in as our first thing and this our second thing. So, or we could go to this step. It really doesn't matter. But this step if it's really complicated. So in y1, we'll put in 5 tan x plus 3. And in y2, we're going to put in simply 9. But this tells me I'm going to need to switch my view window. You need to be keeping track of your view window. Don't be crying to me, I don't see it, I can't see the answer. It's your job to figure out what your view window should be. We are doing 0 to 360, so our x min should be 0, our x max should be 360, and our y min should be, well, if I'm expecting an answer of 9, let's do negative 9 for the y min, and for the y max, let's do 9. Or we could do, if we wanted to see everything, negative 10 and 10. Okay? So we'll go ahead and put those in, and we'll graph that on our calculator. And we are looking for GSolve, or calc, depending upon your calculator, intersect.
And you only have 2 answers.
And what does the calculator show us?
57.9.
So it looks like we have 2 answers, right? This 50, and what's the other one? The 230?
Mm-hmm.
Well, how do we get? It says 57.9 on the calculator. And
57.9? Did we not do this right?
that's on the calculator. It says 237.9 and 57.9.
Well, let's see. Maybe inverse tangent of 6 divided by 5.
I got 50.2.
I got 50.2. Let's go to graph mode.
I
So,
got 50.2 in graph.
okay, just give me a moment. Plus 3 to check what's going on here. 9. View window. Change my view window. Okay. When I graph, GSolve, intersect, I do get 50 and 230. So something went wrong. Maybe you typed something in. Okay, I'll have to go through that later. Let's do a complicated one. Let's say that I have 6 parentheses tan squared x, and then in parentheses plus 15 degrees. So we have a phase shift going on in there, equals 20. Okay, now when we set this up on our calculator, since we are in graph mode right now, so I'm going to go ahead and divide by 6 first thing. Let's get that out of the way. So we get 20 divided 6. Alright, so we get tan squared of x plus 15 equals 3.3 repeated. So we could put that in our calculator as 3 and 1/3, like that. 3 and 1/3. Or 10/3, depending upon which way. So in y1, we could put in this thing, but then I'm going to need to change my view window to 20. So I don't want to do that. So I'm going to go ahead and put this in. So in my calculator, I'll put in tan parentheses. See, I need to be very careful with my parentheses. X plus 15. And we need to square it. And then in y2, I'll put this in. I'm just trying to avoid switching my view window. And I'll put in 10/3. Okay, so we put those 2 in, and do watch that you get your parentheses right there, because we can't put a squared right here like we do. X plus 15 squared, and then we have our 10/3. Okay, and how many answers do we get?
4.
Okay, so GSolve intersect. From my calculator, I get about, I'm going to round to the nearest degree, 46, 104, and 226, and finally 284 degrees. So those are our 4 answers. Now, what are we looking for work? At this step, I need to do what? Square root it. So I'm going to get tan of x plus 15, equals, what is the square root of 10/3? See, I want to keep as many decimal points as I want. So if I can write it in fraction form, I will. I won't be able to do it at this point. So I'll keep 4 decimal places. The more decimal places, the better, the more accurate you'll be. But I need to remember when I take a square root as part of solving something. See, I'm square rooting. I get two answers, right? I get a positive one and a negative one. So this is a negative answer. And then we do an inverse tan. So we get x plus 15. We inverse tan this. And I get about 61.289. And right here, x plus 15 equals inverse tan.
I'm guessing you can have over 1 when you do tangent.
Yes, you can have over 1. And I get, oops, I didn't put my negative in. When I do this one, I get negative 61.2895 about. Right here, I'm going to want to switch to, I'm going to add 360 to that because I want my answer 0 to 360. I could alternatively, if I don't want to do that, I could just continue solving and subtract that 15. So let's do that. Let's subtract the 15. What do we get? Negative 76. I'll subtract the 15 here. So 61 minus 15, and I get 46. Now this one, I'm going to have to add 362 because I don't want my answers to be below 0. And that gives me my 284. Okay, so that's what I am going to be looking for as far as work. And then you can use your calculator to generate these other answers. Now we can get the other answers by thinking, okay, where's tangent positive? Well, quadrants 1 and 3. So I would take and add 180 to this, and that will give me my 226 because that will give me a quadrant 3 angle. And my reference angle here was 76. So if I want my quadrant 2 answer, I will subtract that from 180. So 180 minus 76 will give me my other answer, which is 104. Since that one's in quadrant number 2. Okay? Alright, that's all the new stuff. So now we are ready to be on page 872, and we are ready to solve things.
We do this on the whiteboard.
Yes, we'll be on the whiteboard.
Thank you.